Lesson 5, Applications of Simultaneous Equations. The learning intention for this lesson is that students will understand how to calculate the break-even point of manufacturing and the meaning of revenue and cost. You'll be successful if you can use the CAS to determine the number of items needed to turn a profit. First of all, we're going to start by defining some vocabulary terms. Most of the examples that we deal with in this section are from the business world, so the terms we're going to define come from the business world as well. First of all, revenue. Quite simply, that's the amount of money that you earn by selling a product. It's the money coming in. Offsetting that is cost. How much money needs to be spent in order to create your product, whatever it might be. Related to both of those is profit. Profit is the difference between revenue and cost. It's the money left over after all the costs have been accounted for. It's how much money you're making. And difference, that is difference in the mathematical sense, which means subtraction. So we take all the money that you've earned, which is revenue, subtract all the money you spent, which is cost, and you're left with the profit. One very particular type of profit is called the break-even point. And that's the point where the profit is zero. So the revenue and the cost are equal. At that stage, you haven't made any money, but you also haven't lost any money. And this is a really important point for businesses because they need to know how much product they need to create and or sell in order to perhaps be profitable or at least to not lose any money. There's two functions that we're going to look at, the cost function and the revenue function. We'll start with the cost function. In its general form, the total cost is equal to the unit cost multiplied by the number of items, or months, or days, or whatever it is, plus the initial cost. In this formula here, the unit cost represents the gradient, which of course is M. And the initial cost is the y-intercept, C. That's the part that does not change, stays the same all the time. So for example, if it costs $1,200 to set up the manufacturing line for a model of shirts, and the shirts cost $20 each to make, try and write an equation to represent the cost. Have a go at that now. Well, the equation here, 1,200 is our unit cost, that is our initial cost, so that's our y-intercept, and $20 each, that is the unit cost, M. So the equation becomes C, for cost, is 20 times N plus 1,200. Closely related to the cost function is the revenue function. It's a little bit simpler in its general form. The revenue is the selling price multiplied by the number of items. The gradient is the selling price. It's the unit cost or the unit price. So that's M. And there's no y-intercept. So there is no initial revenue. If you're not selling any items or any products, you're not going to be making any money, so there's no revenue there. So for example, if the shirts that we just made are sold for $50 each, write an equation to represent the revenue. Very easy equation. R equals 50N. 50, of course, is our gradient. That's the selling price, the unit price. Sometimes you may see the letter C used for revenue as well as cost, just for consistency when we're graphing. C is dealing with dollars, with money. Profit and break-even point. And this is what businesses really want to know. So as I said earlier, the profit is found by subtracting revenue, take away the cost. If the revenue is greater than the cost, if you're making more money than you're spending, well, there's profit. Otherwise, if you're spending more than you're bringing in, revenue is less than cost, there's loss. Pretty straightforward. What this means graphically, to find that break-even point, which remember that is where profit equals 0, the break-even point is the intersection point between revenue and cost functions. And algebraically, it's the solution to the simultaneous equations for revenue and for cost. So in our example, the break-even point for our shirts example, so going back to the revenue and cost of the shirts, how would we find that? Algebraically, it's the solution to the simultaneous equations. We have two equations, so it's the solution to the equation for the cost and the equation for the revenue. We've got two worked examples to go through. Have a go at number 1, looking at cost and revenue of selling toy cars, and then come back here again once you're finished. And now you can go on to worked example number 2, which is comparing the costs of two different companies. So it's not quite the same. Rather than cost revenue, it's cost of option A and cost of option B. But the process is really similar. I encourage you to try it yourself, have a look at the example, and then we'll wrap up. So you've been successful if you can use the CAS to determine how many items are needed to turn a profit, if you can create those simultaneous equations and those cost and revenue functions. So what I would encourage you to do, just to test yourself out, is create your own cost or revenue problem to solve, and then solve it yourself or give it to a friend to try and solve for you.